Hi guys, Ed here from Bubble Vans. As you know, we make water heaters that you can put on the front of your diesel heater, and it uses the hot air from the diesel heater to heat the water, and you can get 12 litres of hot water in less than 10 minutes. The most common question we get asked is, why don't you put your heat exchangers on the exhaust of your diesel heater? The exhaust effectively is wasted heat, heat that you can't otherwise use, so why don't you use it to heat water? So what we thought we'd do is set up a quick experiment here in the garden to determine how much heat you could reasonably recover from the exhaust and whether or not it is worth doing. So let's have a look at our test setup. Here we've got a standard 5 kilowatt Chinese diesel heater. Out of the bottom of there we have an exhaust, and this is just the standard length of exhaust which comes with the heater. From there we go into a silencer. After that we've got an aluminium box. That's just a plain empty box. It's got a hole in the back to allow the silencer to go in and the heat exchanger bolted to the front. All that does is it allows the exhaust gas to expand to atmospheric pressure. One thing we're concerned about with these heaters is them sitting up inside because the airflow has been blocked. The theory of this is that if we allow the gas to expand, it won't cause any blockages in the heater itself. We did this experiment with a 2 kilowatt heater. For that we found that a small heat exchanger was sufficient, but for this, because it's a 5 kilowatt heater, we're expecting to be able to recover a lot more heat from the exhaust. So that's why here we've got a 120mm heat exchanger and an 80mm with a standard length of ducting in between, and we're hoping that all of this is going to be temperature resistant enough to cope with 250-degree exhaust gas. So let's find out. Here we have a 12-litre water tank, at the moment full of cold water. We have a small 5-watt pump in the tank just circulating the water. Here you can see this is the return from the heat exchanger. We've got the pump at one end of the tank and this return feed at the other to make sure the water's mixed. And this is where we'll be taking the data from for the water temperature, and this is going to tell us how much heat we've managed to recover from the exhaust. During this test we'll be monitoring two temperatures. Our white meter tells us the temperature of the air coming out of the final heat exchanger, and the black indicator is the temperature of our water. There we go, so the heater's been running for a couple of minutes. We've just had the first injection of diesel, just about make out a few wisps of white smoke coming out of the exhaust here. Looks like everything is good to go. So we're just now looking underneath our first heat exchanger. You can see now we're starting to get some drips, and what this is, as the diesel fuel is burnt, one of the byproducts is water. So the water, it's been obviously turned into a gas when it's been burnt. That flows down the exhaust. As soon as it hits the colder coils of the heat exchanger, it then condenses and will turn back into water, and that's what we can see dripping out of the bottom of our heat exchanger. Not necessarily an issue, nothing to be concerned about, nothing's melting or anything like that, just something to be aware of if you're trying to reclaim your exhaust gases. So what I'm going to try and do now is just get some airflow readings from the heater, just to see how much air is pushing through. So the airspeed here, that's measured at 10.4. Obviously there's a lot of airflow coming around the heater. If I were to block this completely, I can't do that because it kind of burns my hand. But that went up 18-19 meters per second, so there's a lot of air coming through here. If I do this on the inlet, I get typically about 2.5 meters per second. If I come down to the outlet here, just pan the camera down. If I try and do this here, I'm going to have to block it to make sure all the air goes through the anemometer. Don't know if you can see. So that's about 2.1 meters per second. So one thing that has been puzzling me is why the air temperature and the water temperature are this way round. It stands to reason that the air temperature should only ever be above the water temperature. Chinese diesel heaters are great, but they can't change the laws of physics. So we should always expect to have the air temperature measured higher than the water. In this case, the air is 38 and the water is 39, which is a bit peculiar. What I've done is I've actually laid the probe down inside the exhaust to see if that made a difference, and it did come up slightly, but it seems that the prevailing wind is actually coming this way and is blowing up the end here, which is just enough to cool the probe. and make a difference. It's kind of good that these temperatures are similar, but because it just shows that we are reclaiming almost all of the energy available. But you can see there we just got a little gust of wind and the temperature of the air has come down slightly. It's an approximation. It's good enough for this test, but it is something to bear in mind, and hopefully that answers any questions you've had about why this test is not obeying the laws of physics. So, the results. Typically we found that the amount of energy we were able to transfer from the exhaust gas into the water was typically about 0.7 degrees per minute, 0.8 degrees per minute, something like that. That's equivalent to 600-700 watts. Just to compare that to the Bobble products, the big bobble heater is able to transfer 2 degrees per minute, and the bumper is 3 degrees per minute. So we're able to get much more energy from the main body of our heater than we are from the exhaust. It is something that you are more than welcome to try. The advantage of taking from the exhaust, like we said, is that it is effectively wasted energy. That's just going to go off to the atmosphere, so if you can use it for something useful, absolutely great. Really, it's only useful in the winter. The reason that we concentrate on putting the heat exchangers on the front of the heater is because then that sucks all of the energy from the main airstream, so that when it comes out into your van, that's typically 10 degrees above ambient, and you're barely going to notice that temperature. If you are using this in the winter year round, what you may choose to do is just heat your water using your exhaust and just heat your van using your airstream. The advantage of this is quite simply that once you stop pushing water through that heat exchanger, the water in there is going to bubble and boil. It's going to make some noise. You may find that annoying, but also it means that all of the energy in your airstream is free to heat your van, which in the winter months is definitely beneficial. So if you do install a system like this, then maybe you want to have your heat exchanger underneath effectively your only one, and then the ones that are in your van have those removable, so you put them in the summer and then you remove them in the winter. If you are going to do it, you probably should be aware of sooting. These heaters don't like to have the exhaust flow restricted in any way. This can cause the gases to not flow through the heater correctly. The diesel won't burn at the right temperature, and you will be left with deposits on the inside of your heater, which is what you want to avoid. So whatever system you go for, make sure that you're expanding your exhaust air to atmospheric pressure before you're putting it through any heat exchangers. Hope that's been interesting. Any questions, leave us some comments below, or send us an email via the website bobblevans.co.uk. Happy building!